And welcome everybody to the Daily Space Weather Smash Show, coming at you from the Smash News Network, least busted name in news, bringing you the freshest imagery of the sun you'll find anywhere in the known universe. Let's do it. We're going to start by going around the horn here, starting off in the northwestern limb. We've got, well, lots of sunspots. Here is your southwestern limb. Lots of filaments down there. Plenty of stuff to talk about. Also some weather coming at you later in the video. There is your southeastern limb. Huge snaky filament here. Zigzag shaped filament there. Also some prominences down here by the south solar polar region. And of course, we've got some new sunspot groups that just rose. At least one has gained beta class classification since yesterday. Also some well-defined coronal holes coming in, and I believe a coronal mass ejection striking right on time for our forecast from the 19th. There's your full disk view in these same wavelengths. That's 193 plus 171 angstroms. Let's take a look at sunspots next. That is yesterday plus today. We're going to zoom in a little bit closer here as we do have some sunspot evolution happening here. So we've got some growth down here, some degradation up here. We've got some migration over here. And this new sunspot group, the largest one that's risen here, now does have some trailing umbrae, so it is now beta gamma class. And as these two huge groups approach the limb, their likelihood of producing major flares is very high. I think we've got an X-class flare coming, folks. At least one, maybe more. Here is your colorized magnetogram. That's also yesterday plus today so far. We also had the largest flare of the past 24 hours happen as we did show prep here. So we finally had an M-class flare. We'll talk about that in a moment. First, a little bit of what's going on Croissant Earth. So, Shiva Luch on the Kamchatka Peninsula continues to explode. It's producing a 16,000-foot ash plume. That's a flight level 160. Ibu, 8,000-foot ash plume over Halmahera, Indonesia. Semeru, flight level 140 as Semeru explodes. That is a 14,000-foot ash plume. Popocatépetl, the largest ash plume in the world there, extending to 28,000 feet of altitude. It's a flight level 280 over central Mexico. Fuego in Guatemala exploding, flight level 150. Sangay in Ecuador exploding, flight level 190. 19,000-foot ash plume. 14,000-foot ash plume over Ravenador. Cotopaxi exploding. And on the 20th of January, it produced 1,796 tons of sulfur dioxide. And last but not least, Sabancaya in Peru, also exploding, flight level 250. It's a 25,000-foot plume of volcanic ash. Let's see what's going on seismically speaking. And the largest earthquake happened at the Reykjanes Ridge. It was a 5.7 magnitude. We'll get to it. As we scroll up the list, if we miss anything, let us know. We did have a lot of quakes here, but no major quakes. So that's a great reminder that any earthquake can be a foreshock. Be an asset, not a liability. If buildings start to fall, have an idea of which ones might fall. If there's an ancient building facade right where you'll be evacuating if you happen to leave your building, realize that that facade might be falling on your head as you exit the building. If you don't have a bug-out bag, at least have a bug-out plan. Know what's likely to collapse and what's likely to stay built. Modern buildings built to modern earthquake building code are a lot safer bet than ancient buildings made out of rock and block. Anyway, there's the Reykjanes Ridge quake 5.2, and that was a foreshock to this 5.7. That was the largest quake of the past 24 hours. There was also a 5.1 at Indonesia. There is a location of that. And there's an aftershock at the Reykjanes Ridge, a 5.3. So the three largest quakes all came from the same location there at the Reykjanes Ridge. south of Greenland and Iceland. Tonga also had a 5.0. And if there's anything we miss in the coverage of earthquakes, drop us a line in the comments and let us know. Next, let's get back to space. Here's 211 plus 171 angstroms. Great wavelengths there to show coronal holes and magnetically suspended filament loops. Let's subtract 211 and add 304 angstroms. There's ionized helium plus ionized iron, and good morning, Mike Bordages. Next, let's subtract the 171 angstroms altogether and just look at ionized helium. These are all the past 24 hours, by the way. And if you're wondering about overall solar activity, well, it has dropped a little bit here. Once again, it is now down to 209 solar flux units for the 10.7 centimeter radio flux. Now, that radio flux comes from the upper chromosphere and lower corona, which is this area right here. And that number represents pulse flux units, solar flux units rather. Those are 10,000 joules of radio flux density. Here we are dropping below 210, the current radio flux number 209 solar flux units. And looking at the Space Weather Enthusiast dashboard here, therefore NOAA forecasted for geomagnetic unrest right here around when we're creating the video. So maybe they watched our video forecasting a minor CME impact causing a KP4 or maybe even a KP5 minor geomagnetic storm event. We do seem to be seeing somewhat of a signal there. We'll take you to the real-time solar wind here in a moment. First, Earth's planetary K index. So we may see this jump up to 4 just as NOAA forecasted and just as we forecasted the CME to arrive midday today. Mid to late day today, so it looks like it's showing up just on time there. We forecasted that back on the 19th. Next, the last 4 hours of Earth's magnetic moment from space. We show it daily on the channel. It's a great way for people to visualize what Earth's magnetic moment from space likely looks like. That is derived from the space weather modeling framework. Again, that's the last 4 hours of magnetohydrodynamic pressure. And there's the arrival of that minor CME impact. You should also see that happen at the end of the ground magnetic perturbations map. This is Earth's magnetic moment from the ground for the past 4 hours. And you can expect to see a similar increase there in the geospace delta B, changes to Earth B field right here at the end. Didn't really show up. Anyway, let's move to the real-time solar wind. And we're talking about this signal right here because we definitely do see a signal here just in the past, about the past hour. We see a change in the phi angle. We see a change in the magnetic field, an increase in the solar wind density, the solar wind speed, and the plasma temperature. All the trappings of a coronal mass ejection strike, just as forecasted. It'll probably be minor. In fact, it may already be subsiding there. But that does certainly look like a signal. An increase of about 50 kilometers per second for the solar wind speed, and an increase of about 8 protons per cubic centimeter. So quite diffuse as we forecasted. Anyway, the current conditions have dropped back down here, 436 kilometers per second for the solar wind velocity, solar wind density about 4.5 protons per cubic centimeter. Next, we'll look at magnetic data as we do on a daily basis on the daily space weather. There are your GOES magnetometers. And next we'll look at the heliospheric current sheet. As the north pole of the sun rotates out towards stereo B, which is this little plus sign right here, that's stereo B, located at Lagrange point 4. We've got the south pole current sheet rotating in here. No sudden changes here expected. Let's take a look at our line of sight field plot. There is what's happening in terms of the solar polar fields and the solar B field depicted in blue. Next up, coronal holes. So we've got a well-defined coronal hole here just rotating through the Earth-facing zone. It is of north pole orientation. There's a second one a little bit to its north. So North Pole, there's a second one up here. It's a little smaller. And it'll be more evident in the 211 angstroms wavelength from SDO. So let's go to that next. So we can expect a high-speed wind from this arriving on Wednesday. Early in the day on Wednesday. Expect to see that on the 25th. And that could be an extended coronal hole high-speed stream. I expect it to arrive there'll be a significant signal from that. When that does show up, it'll be very obvious. We'll see a spike in the solar wind speed, and then a decrease in the solar wind speed and an increase in the... we'll see a spike in the solar wind density, and then we will see a spike in the solar wind speed after the density drops off. The telltale sign of coronal hole high-speed streams. So next we'll go to sunspots. And looks like 3200 hasn't been named yet. 3200 needs a name. It's already beta gamma class. So at least a little increase in the sunspot number here from that new sunspot group. And we're going to show you some more detailed imagery of that. But first, take a moment to press like and subscribe if you enjoy the content. Thanks to our new and old subscribers. Congratulations on realizing the channel exists. If you haven't checked out our playlists, all kinds of interesting stuff there besides daily space weather and meteorology segments. So go check those out. Everything from product reviews to terms defined, interviews with other content creators. So check those out. Press the notification bell. No guarantees on whether you'll actually be notified. We'll talk more about that in a moment here about joining the Smash team. Today's featured product is do not pole vault the caldera. Because to quote Winston Churchill, if you're going through hell, keep going. And if you're going on a volcanic vacation, leave your vault pole at home. Don't pole vault the caldera. No matter how bad things look, don't worry, folks. They can get much, much worse. However, our finest days lie ahead, so plan accordingly. Centralization and censorship are dead. And organizations that prop those things up are zombie organizations, moving forward only on their own momentum, not through any innovation or skill. If you click the links below the video, you'll find one of them is the Red Bubble Shop, where you'll see the products in order of best selling. There's a quick rundown of what they include. We decided to start putting out merch because reasons, and those reasons are that we make just this side of nothing to put the content on YouTube. So if you want to support the channel, support us on Patreon if you like, if that's the most convenient way to do it. 3 membership levels there available at Patreon, but the official subscription services site is smashomash.com/smashteam. So we launched that in October of 2021 because, well, we needed additional capabilities that Patreon didn't offer. So consider becoming a member at the Smash Team, especially the silver or gold level. The best value is the gold annual paid-up subscription. It's almost like getting 4 months of a gold membership for free. We've also already explained to our gold members the mechanism underlying the solar sunspot cycles. That will be featured in the paper that Eugene and I are writing to explain the mechanism that causes the solar polar field reversal and sunspot cycles. So that should be interesting to say the least. Again, join us at the gold level if you want to hear about it. We posted about it long ago. Maybe we'll put up another post about that today or something like that. Smashomash.com/smashteam. You'll also get email alerts about our video postings, since we don't trust certain video hosting organizations to actually notify you when the content goes up. There's also a bronze level for those of you unable or unwilling to open your cobweb-encrusted wallets. So hit the homepage at smashomash.com and welcome to the Neo-Renaissance. Smashomash.com launched in 2019 in response to pathetic censorship by Facebook. So we built our own site, and there's also a forum there. You can find links to the merch, links to the YouTube page, and all over social media. And let's get back to space. So here are sunspots and 171 angstroms. This group down here is still not a sunspot. It's only a plage. So we'll be keeping an eye on that. And when I say ion, well, pardon the pun, here's a zoom in of those same bands, the SDO continuum plus 171 angstroms. And here we've subtracted 171 angstroms just to include the SDO continuum. And that, my friends, is a lot of sunspots. So like all of our custom Helio viewer movies, typically that is 24 hours. And here is our ghost proton flux. No spikes in that in the past 24 hours. A little bit of interesting conversation going on Twitter about what caused this second spike. Join us on Twitter for our comments on that, perhaps. And there you can see that last M-class flare. That happened right as we did show prep there. It was a very small M-class flare. It was an M1.15. It looked like peak flux there was at about 12:20 Universal Time today on January 22nd. Let's take a look at the activity here in 131 angstroms. And I believe that M-class flare came from this area here. And you are able to see a little bit of the plasma bridging here. So great example here of this plasma bridging going across the solar equator right here. You can sort of see some activity happening there. Some plasma being exchanged there between those sunspot groups as they are parallel to each other across the solar equator. So the likelihood of that to produce a major flare, especially if one of those sunspots grows or degrades, is very, very high. And the closer it gets to the limb, the more likely we are to see an X-class flare from that region. Let's also show 94 angstroms. Yeah, so that M-class flare came from this area right here. You'll see it right at the end of the video there. So that remains the most likely place to see a major flare, like an X-class flare. And there may be a lot of plasma suspended by the magnetic fields of those sunspot groups that is not evident in the imagery here because, well, it's sort of, the loops are sort of oriented towards you as the observer here, and that sort of makes them very difficult to see because of contrast or lack thereof. Next, looking at a star chart, and if you're up before dawn, you may see Mercury rising ahead of the sun. There's the latest imagery. That's what's going on over Lehigh Valley, Pennsylvania. Coming at you a little bit on the late side today, and let's do a solar system forecast. So happy new moon to all my reverse werewolves who sleep well at night and are happy, productive members of society who don't cannibalize humans and do other satanic rituals in the middle of the night. New moon. It's the time of power for reverse werewolves. Are you a reverse werewolf? Let us know in the comments. Here's your solar system forecast. We'll advance this 1 week. Keep in mind this imagery is not to scale. Those things are very far apart. And in 1 week we will have a gibbous waxing moon. Next, some coronagraphs. And we haven't really seen any significant coronal mass ejections here in the past 24 hours. There are 85 frames from yesterday. And here are an additional 24 frames from today. It's been very calm in terms of coronal mass ejections. The likelihood of those remains kind of high. There are still quite a few filaments on the Earth-facing portion of the solar disk. Let's take a look at Stereo A's coronagraph as well as Soho Lasco C3. Again, not a lot to cover in terms of coronagraphs. CME activity has been quite minor. So no additional Earth-directed CMEs here expected. And here are our 24-hour HelioViewer movies. There's the past 24. Let's zoom it out. And let's zoom it out even farther. And that brings us to filaments. So it took us a long time to figure out which tabs to cover. Here's our next one, our filament view. So yeah, lots of filaments here. Lots of filaments indeed, especially in the northern hemisphere, but quite a few in the south as well. Let's zoom in a little bit closer here at the Cerro Tololo, Chile, ground-based solar observatory, showing hydrogen alpha, by the way. And yeah, filaments, 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 filaments. I think this one's the Dick Van Dyke. And I'm not sure if any of these other ones have names. Although this one here is the James Comer, I think. That prominence, that's the James Comer filament. Anyway, let's bring up the latest image here and play a game of... And by the way, you have to name the filaments on Twitter. So you have to either comment or tweet and tag us in the tweet if you want to name a filament. Then we will repost or retweet or whatever you call it. Don't worry, Twitter. I know you can handle it. You can't handle removing shadow bans, but you can handle tweeting. Anyway, so let's play Name That Filament. Whichever one. Just don't name this one. Just don't name the Dick Van Dyke or the James Comer. And make sure you join us on Twitter to see all kinds of things that you can only see on Twitter. So here's the last 24 in 171 angstroms all by itself. It's the house favorite wavelength. Always love the 171 angstroms wavelength that shows the lower corona and the magnetically suspended plasma of a certain species of ionized iron, its ultraviolet light output. Not visible from the ground, it's filtered out by the atmosphere, that extreme UV. So we use spacecraft like the SDO. So here are the last about 2.5 hours from the GOES 16 SUVI. And I would say once again, keep an eye on this area, because that is just a ticking time bomb there. So we expect that to produce some significant flares here, especially as it approaches the limb. I mean, I think the likelihood of that producing an X-class flare as it approaches the limb is probably 80%. And again, any major degradation or even growth of those sunspots could cause that plasma bridge to collapse. And if that happens, the pathway of those electrons that are traveling around that bridge will drastically change. And that is what many of us believe a solar flare to be generated by. Anyway, let's continue on here to our bonus feature segment. Space weather and the satellite's community dashboard here showing some minor charging hazards for surfaces of satellites in the Central Pacific. Nothing too hazardous there. That's from low energy electrons on the outside of spacecraft. Electron flux here coming up off the floor. So we saw a very low electron flux here for a solid week practically. And now we're seeing a normal sort of mid-range of the electron flux, which is measured at the F layer of the ionosphere, by the way. And there is the forecast model. NOAA expecting an increase in the electron flux. And I don't know, no argument. No argument from me there. I'll just leave it at that. It looks like the CME impact was glancing, barely even a signal of the impact, so we'll have to see what happens, though there could be some additional ejecta. There's the one-year chart of the electron flux to put it in context, and here is the F layer of the ionosphere. So this slice of the atmosphere, we're going to show you the vibrational frequency right in this area. The lumpy F layer. So here's the raw vibrational frequency in megahertz. And we are seeing huge anomalies continue. And if that's not abundantly clear by looking at this imagery, the anomalygram will make it clearer for you. So that's the raw vibrational frequency going on at about 300 kilometers of altitude. And here is the anomaly in megahertz from a 30-day median. You'll see some rapid swings here. Some rapid swings around the South Polar region from high to low frequency anomaly. High frequency anomalies north of the equator. And of course the South Pacific anomaly having left the South Atlantic anomaly area and left the South American continent area. Now it's over here. It's super clear from the anomalygram where it is. It's right there. And the South African anomaly is now way up here instead of down here by South Africa. So interesting anomalies continue in the ionosphere. Let's show the latest image as we do. There is the latest image. That's 1300 universal time ionogram. And there is the anomalygram. We'll also show the total electron content. Those free electrons between your GPS satellite and your handset can cause a signal refraction, which can cause GPS errors of thousands of miles. We've actually covered it. Follow us on Instagram for some posts about that. And here's our total electron content, and it's quite anomalous indeed. So you can see these weird bands of low electron content. Also, this weird spot over the Caribbean and this weird spot over southern South America, where we're seeing anomalously low electron contents. Yet across much of the planet, we're seeing anomalously high electron content. So perhaps that's giving us some insight into the generation of Earth's magnetic field, but it's certainly very anomalous total electron contents, and you can expect massive GPS errors over most of the human population's range. Huge GPS errors expected there. That is the free electrons between your ground-based GPS handset and your GPS satellite, which is located at about 12,500 miles of altitude. Last but not least, we'll show the latest intensitygram and the latest SDO magnetogram, because this group has now become beta class. So that's sunspot 3200, and it has gained a second trailing umbra there since we did show prep. So that's now a beta gamma class sunspot group. It may even be beta gamma delta class, but it's kind of in the process of rising. Also, another sunspot group just formed right here. So there's another sunspot. Activity is not dropping off, folks. If you were basing your business model on having 0 sunspots for years in a row during a solar cycle, get a new business model, because it's obvious that there are lots and lots and lots of sunspots. So a little bit less than yesterday, it looks like. But still, new sunspots showing up on the daily. Next, it's time to go to the meteorology segment. So once again, take a moment to press like and subscribe if you enjoy the content. Tell your friends and foes about us, as it's been less than optimal in terms of being recommended by certain organizations. Alphabet, Meta, Apple, and Twitter. Yes. So here is the jet stream scenario for the North Polar region. So there are the northern hemisphere jet streams. Quite a coherent jet stream over here, which is over Asia and the Western Pacific. Here are the jets of the southern polar region. And there are the jet streams of the eastern world. Surface winds are noted here. Surface winds of the western world noted here. A strong low is about to form off the coast of New Jersey. We've got snow coming to Pennsylvania. We'll cover it. There are the jet streams. Quite chaotic jet streams there in the northern hemisphere. Some major kinks. Jet streams of the central world are looking like this. And these are the surface winds to close out our global wind map. And let's move on to see what's going on as far as clouds and fog over the Americas. Rapid cloud nucleation once again happening in South America. It is summertime in most of the continent. That is 3.9 nanometer infrared radiation. And here is your weather.gov map. We'll scroll down so you can see the key. We're expecting most of Pennsylvania to get coated in snow here. We'll show you the snow forecast in just a moment. If your location is lit, click it on the weather.gov map and get your weather warnings. So we're starting out with temperature. This is temperature in degrees Fahrenheit for the next 3 days. So that's a 72-hour GFS temperature forecast. Dag, it's going to reach like 90 degrees in Cuba. As far as Pennsylvania, it's not going to get above 40 for the next 72 hours. That's your 72-hour temperature forecast. Here's your 72-hour pressure and precipitation forecast. Strong storms there moving from Mississippi up to the northeast. And some heavy snow there coming to Oklahoma. Check it out. Oklahoma and Arkansas expecting some heavy, wet snow. Let's take a look at how the total precipitation plays out, since some of that will be in the form of rain. There's the total accumulated precipitation there, expecting some very heavy rains there around coastal South Carolina. Like 3 inches, maybe? These are all the GFS 72-hour forecast, by the way. And since some of that precipitation will be snow, let's show that as well. There is the total accumulated positive snow depth change in inches for the next 72 hours based on that same GFS model. We'll also show you the Euro model here and the differences between the GFS and the Euro. Anyway, expecting like 2 inches of snow over most of Pennsylvania. Some portions of Arkansas there expecting pushing a foot of snow there, over 6 inches. Anyway, here's your windy.com map. So this is the European forecast for the next 3 days. And we'll show you the difference. There's the European forecast. Here is the GFS. And GFS calling for heavier snow there in Arkansas than the Euro model. Euro model calling for heavier snow in Texas. Anyway, again, there's the GFS for the next 3 days. And there is the Euro for snow accumulation. GFS and Euro. And we had some lightning here over the Gulf Coast, also into Georgia and South Carolina. Let's see if we have any active cells at the moment by checking our lightningmaps.org. Next time you hear thunder, scope it out. It's pretty sweet. We do have some active strikes here, I think. Do we have thunder? Is somebody playing an AC/DC song in the Gulf of Mexico? Anyway, those are our active lightning strikes. It looks like we have no terrestrial strikes in the U.S. here at the moment. And let's move on and close this mother out. So we'll start out with the U.S. Doppler radar map that shows vertical motion of water droplets and ice crystals. How about if we focus on the lower 48? Lots of moisture coming to the northeast, much of which will be in the form of snow. Here is your clouds and fog map. It's still dark over half the country. And there is your water vapor map. Here's your recap. And that is where we shall close things out. Thanks for tuning into the Smash News Network, least busted name of news. Once again, congratulations on realizing the channel exists. Please support the channel with a like, subscribe, press the notification bell, leave a comment, press share, tell your friends and foes, etc. If you're an influencer, drop us a line. We'll be more than happy to appear. Thanks for leaving additional contents, Mike Bordages. No, you the man. All right, we're out. Have fun. Don't do anything I wouldn't do. I guess that doesn't narrow it down. But in the meantime, I've been your host, Dan, a.k.a. Smash-a-Mash, signing off. And may that solar wind be at your back. Opinions in this video, not necessarily the opinions of Smash News Network, least busted name in news.